Hey, welcome to Boston Python. This is Wednesday night, February 17th, 2021. We're going to have two talks tonight about debugging, two different approaches to debugging. And the first talk is going to be from Emily Charles. And Emily, you should be able to share your screen.
Yeah, let's do it.
Now, Emily, how do you want to handle questions? People can type questions in the chat. I'll be monitoring the chat, and I'll break in if it's something that really should be covered in the flow.
Sure,
But
throw them at
we
me.
might save it till the end if it's more of a tangent.
All right,
All
so
right.
hoping that everybody can see the title slide here.
Looks good.
Excellent. All right, let's dive in. So tonight we're going to be talking about debugging without print, more specifically using the Python debugger PDB. And here's kind of what we're going to talk about. And this talk assumes zero prior knowledge with debuggers. So we'll start from the very beginning, take you all the way up through what it is, how to use it, and kind of next steps with the idea of getting you functional in half an hour. So here we go. So starting from the very beginning, what is a debugger? So if you're new to programming, new to Python, you might be familiar with the workflow of running your program, something goes wrong, and you print some stuff out and run it again. And maybe you iterate on that process a frustrating number of times. So this is where a debugger comes in. In its simplest form, a debugger is a tool that helps you look at your program while it's running. So it introduces this concept of stopping your program in its tracks and letting you kind of look around at it in its intermediate state after it's started, but before it's finished. And so you can kind of poke at the internals of your program, which is kind of new and interesting. So what can it do? Like we said, it can kind of freeze frame your program. So all programs go through and execute their commands one by one. Let's not touch on async stuff. So let's say just one by one for now. And so you can stop at any one of those steps and kind of inspect what the state of the program is at that point. So if you are in the habit of like printing out your variables at different steps, this kind of tool can help you eliminate some of those extra commands. And the last thing it can do, which is really important, is you can advance the program at your discretion. So don't let the computer take over the flow of the program, but you can say, okay, I'm ready, execute the next step. And we'll get into that a little bit. So what can't it do? Sadly, it cannot actually find the bugs for you. That's another skill and another talk. So we're going to go over kind of the crunchy technical way of looking at your program, and then developing the skill of debugging is another separate. All right, what is PDB? PDB is the standard Python debugger. So in typical Python laconic style, we've abbreviated Python debugger to its three letters, PDB. It's a module in Python. If you have Python installed on your computer, you have PDB. And this gets a smiley face for me because dependency management is no fun. And I always like to use the packaged up thing first before going and looking for an alternate solution. And lastly, PDB is a command line tool. So if you come from the world of GUI debuggers, say you use something in VS Code or PyCharm that lets you like click a breakpoint into place, this is a little different. It's going to let you type in commands to the debugger on the command line. And there are certain ways to interact with that, and we'll get into the commands that you'll be typing. So if you're comfortable with the Python shell, this might be the thing for you. And if you're coming from the world of GUI debuggers, then maybe a new area to explore. All right, how do we use it? So there are two basic ways to use PDB. Option one is to start the whole program under PDB. So using PDB to go through it and process your program. And what this will do is it will spin up your program and stop before any line has been executed, even the import statements. And from there, you have control over how the program advances. The second option, which is my favorite, and I think a lot of people's favorite, is to use breakpoints. And again, if you're new to debugging, this concept might be new to you. A breakpoint is just where you point at your program and say, okay, here is the place where I'm interested in stopping and looking around. And in PDB, you do that by typing a line of code into your program or multiple. And there are two ways to do option 2. One, if you're using Python prior to 3.7, and one if that's available to you if you are using a newer version of Python. And for this talk, I'm going to be using option 2, so I'll be using breakpoints, and I'm going to use this top syntax, even though it's not as nice as just typing breakpoint. This top one is available to you no matter what version of Python you use. So in the interest of being a little bit more accessible, we'll use import PDB with the set trace function. Okay, so what can we do? So now that we've set a breakpoint, what can we actually do once the code stops and says, okay, we're stopped, now what? And so the first kind of thing that you might want to do is just look around at the state of things. And I'll point out a couple of helpful commands, then we'll jump over to the code and see how they work, and then come back and discuss a couple more commands, etc. So the first thing you might want to do is say, like, well, what's going on near where I am? What's the statement that just executed? What is going to execute next? And that's going to be the command list. And the way I've written it here is both in the long form list, and you can also use abbreviations for most, if not all, commands. So you can also abbreviate that as L. Another thing to kind of replace print, you probably want to print some stuff out. So PDB offers 2 options for that. One is just a straight print, which evaluates and then prints a Python function that you type after it, or a chunk of Python that you type after it. And then one that I really like is pretty print, which gives you some formatting that you might be used to in like JSON formatters. It's just a lot nicer to parse, and I'll show you a little bit of that in a second. And the last thing that you can do is just write plain Python. It's sometimes useful to you to do some sort of operations, whether it's like as simple as adding 2 numbers together, or writing a little list comprehension or something. Any command that you type into the PDB prompt that is not recognized as a PDB command is interpreted as Python, which is really, really helpful. All right, let's look at some code. Okay, so here we are in my editor. So let's put PDB on hold for just a second while I explain 2 things. One is that even though I'm using, this happens to be PyCharm to edit the code, I'm not using any other function of PyCharm. I could just as easily do this demo from the terminal, from the command line, just using Python as it's installed in my system. So I'm not using the PyCharm debugger. I'm not using the PyCharm interpreter. It's literally just to edit the code. The second thing I want to go through is just what this program does, so we're all on the same page. I'll do it in 4 sentences or less. Okay, so this is a little program that imitates the game show Jeopardy, or starts to. And if you don't know what Jeopardy is, that's okay. It's a question and answer trivia game, and questions are worth money, and that's kind of all you need to know. So what I'm doing here is I'm loading in some questions. I'm taking a little slice of it. I'm processing it a little bit. And then I'm pulling a single question out of a particular category. And that's all it does. So let's see that run. So I'm going to run it from the terminal, Python jeopardy.py. Okay. So it says, here's your question about architects. That's the category we asked for. And this prompt, which you can attempt to answer if you'd like. So yeah, let's say that something wasn't working here and we wanted to take a look at what's going on. So I'm going to go right here. Say we want to take a look at this data. We don't know if that data got read in properly. So I'm going to put a breakpoint here. So I said we would use the original syntax, import PDB, pdb.setTrace. Okay, so now what happens if we run this? All right, we've got something new. We've got these two new lines that weren't there before. We've got this line, which tells you where you are. Here's the program that we're running. Here's the line that we're on. And this is your context or your scope. And then it's also pointing at this line, which sure looks a whole lot like some source code up here. And that's, as it turns out, exactly what it is. So let's say that we want to, say we didn't have this window up here. Say you're running in the terminal. Let's list out the source code around the line that we've stopped on. Let me make that a little bit bigger. Okay, so what this has done, by default, PDB prints out 5 lines of context on either side of the line in question. So the little caret says we're right here, and it's helpfully printed out a little bit of context before and a little bit of context after. So that's helpful in, like, if you're going to step through your program, you kind of want to know where you're going. Okay, so what else did I say we were going to do? I said we were going to do some printing. So let's take a look at this raw object. This is loaded in some JSON. Say I don't know what it looks like. Let's print out raw. Oh boy, that's a lot. Let's print out the first element of raw. That's a little easier to handle. Okay, a little bit better. We know that some data is being read in. It looks like this is a list of dictionaries, but that's a little bit hard to parse. That's kind of a wall of text. So let's pretty print what's there. Okay, so that's a lot better. Now we can see that this is a dictionary. It's got some keys in here, some things that we're interested in, the question, the answer, the category, all of that looks like helpful information. So that's great. I'll also point out that you can set variables and, like I said, type some Python code in here. So we can say, oh, geez, how should we do this? No, let's not do that. So we can say type of raw. Whoops. There we go. So we know that type is a list. And so any Python code that you would like to type here is valid. Okay, so that's kind of looking around here. So let's comment out this breakpoint. I'll jump back to these slides and we can discuss the next set of commands, which is going to get into, like, okay, let's move on from this breakpoint. So navigating around your code. So you probably don't want to stay stuck at one point in your code, or maybe you do, and that's a very simple case, but usually you'll want to go line by line in your code and see how the state changes with every line. Okay, so the command that I use the most and the command that you are probably going to use the most is N for next. And what that does, it executes the line that we're on and moves on and breaks on the next one. So it's a step one line command. So after you press next, you'll still be paused. It'll just be one line later than you were. Another helpful one is continue. So continue is like a bit of a fast forward button. So continue will go until one of two things happens. One is you hit your next breakpoint, or the program ends. So this is really helpful if you have a couple of areas of interest in your program that are, like, causing you trouble. You don't have to limit yourself to just one breakpoint. You can, pause at multiple different points. Where am I? So I'm sure we've all gotten lost in the terminal before. This command is really helpful because it just reprints the line that you're on. It's very similar to list, but list does some weird things with, like, it doesn't always give you the same thing back. Like, it's not iterative. I don't remember what the word is, but where will always give you the line that you're currently on. And then always helpful to know how to quit. A lot of command line tools kind of obfuscate this, but Q or typing quit will get you out of the debugger, and it'll actually exit the whole program. All right, let's see those in action. Okay, so I'm going to put my next breakpoint here. I'll just copy this from up here. Let's go here. Whoops, some auto formatting that I don't really want. Okay, so let's run this again. All right, so here we are. We can see that we're on this line that's assigning a value to this variable category. And one thing I want to point out that is kind of a gotcha for new debugger users is that, here, let me show you. If we try to print out category now, it says category is not defined. And so the kind of gotcha there is that the caret is pointing at the line that is about to be executed and not the line that has already executed. So if we say next, we've advanced one line. We're right here now. And now if I print category, all right, the category was history. That's great. So yeah, let's see next in action just one more time. One helpful thing about the debugger is that you can kind of trace the flow of the program easier than if you just had let it run. So let's say we don't know what the result of this if statement is about to be. Well, instead of like thinking about it real hard or printing it out, I can just say next here and see which line I'm on. I'll list it out again. There we go. So we've skipped this upper section and we moved straight to the else clause. So now I know that this category history was not in this dictionary. So that's kind of the kind of helpful information that you might be able to learn from one by one stepping through your program. One other thing that, oh yeah, I want to demonstrate the continue command. So you might think that, okay, there's only one breakpoint in the file. If I hit continue, we'll go all the way to the end. But in fact, because this breakpoint is in a loop, it gets inserted like every time the loop runs. So you can see that we're back at this breakpoint up here. If I advance, whoops, that's not what I want to do. If I advance with next one more time, actually, for reasons I won't get into, I'm doing that again. Print the category again. Okay, great. So we know that we've advanced one time through the loop, and we have evidence that this category has changed, which is good. And so now I will use Q to quit. We've exited out of the program, and I will jump back to the slides before we do our last demonstration. All right, navigating continued. So you can get actually pretty complicated with how you're stepping through the program. So one thing I want to touch on, I won't go too deep into this. That wasn't an intentional pun. There's this concept of not just executing the next line, but if it's a complex line, say they're like nested functions, you can step into each of those functions. And that's really helpful because you don't want to have to list your functions on separate lines and save the results in variables. Like sometimes you want a one-liner. So step lets you dive into the function that's contained in the line. I'll show you that in a second. Step is kind of, I think, not a great name. A lot of GUI debuggers call this step into, which is probably a little bit better because step and next seem a little bit too close for my taste. But the step is diving into a function. And then the thing that you might want to use in conjunction with this is return. So that's kind of like continue, except it lets the program run until the current function returns. All right, let's go see those two last things in action. Okay, so this is the line that I want to pause on. So I will, just for fun, let's say breakpoint. So that'll work. So yeah, let's run this. Okay, so let's say I don't want to just get the question out of this. That's printed out on the next line. What if I want to inspect this function get question? So I'm going to say step, S for step. And now if we list that out, we're at this function definition get question. So we're calling get question down here. And now we've jumped to the definition of get question. So I'll say next. Whoops. All right. So now we're on this return line, and we can keep doing that. So I can say step again, and we've called one more nested function, two actually, but I'm not going to touch on the random no choice. So we have one more nested function, get questions, defined up here. And so now we're at this line here. So we're 2 levels deep now. And let's say I want to get back out. I've done all the work that I need to do here. I'll hit return. And Whoops. Where am I? Okay, so we've returned to, I don't know where we've returned to. Oh wait, there we are. Okay, so we returned back to.
Use W.
Yeah, W for where? Oh, it's just small. So yeah, we're back at question equals get question. I did it enough times that I jumped all the way back out of the call stack, and now I'm back on top. Sorry, I got myself lost there.
No, actually, I think you're actually still at the random.choice line. So where is showing you all of your stack frames? The output here is very confusing. It's got an arrow pointing to two different source lines because you're kind of currently at the function call and at the line within the function.
Yeah. Okay, there we go. Yeah. Okay, thank you. Yeah, okay, so now we've gotten all the way back out of those nested functions and we're right here. Yeah, thank you for that clarification. All right, so that is kind of the basic list of commands that you might want to give to PDB to kind of look at your program and kind of poke at it and see what's going on. To start wrapping up, I do want to say that like debuggers have their time and their place. And I know we'll get into this a little bit with the next talk, but I'll say this. While I was preparing for this talk, I forced myself to not use print for a whole week. And every time I wanted to debug something or even look at anything, I forced myself to use PDB. And that went okay. I will say that print has the virtue of having no overhead. You don't have to depend on any packages. So it's always free. It's probably not changing anytime soon. It's always going to be there. You don't need to worry about having the most updated version of print. So that's really nice. It is safer to leave in production code. So if you leave a couple of dangling print statements in your code and you push it to your production server, nothing is going to break. But if you accidentally push a breakpoint, then you run the risk of the production code grinding to a halt and waiting for you to respond to the prompt. Unless, of course, you've done the work of making sure that that doesn't happen. So yeah, just something to be aware of. So where the place where I found myself in was that I use print to find out if I'm actually confused or not. And if I am confused, then I jump to PDB. So if print gives me back the result that I was expecting, great, I move on with my life. And if it doesn't, that's kind of a cue to do a little bit more formal digging. All right, the last thing I want to discuss is you're by no means limited to PDB as a debugger. There are 1,000,001 of these out there. Like on the package index, you can look them up, and I'll discuss 4 of them. One of them is IPDB, one of the more popular ones. And with these debuggers, you get a couple of benefits over PDB. And this first one is pretty obvious. You get some syntax highlighting here. And I don't know about you, but I find that wall of white text on a black background pretty hard to parse. So it's really nice that you get these color-coded things. So constants are one color, line numbers are another, keywords are another. So that's really handy. This is PUDB, so we get quite a bit more complex here. So this is approaching the world of graphical debuggers, where you can see you've got the source code with its little highlight on the left. You've got it's automatically printed out the local variables for us and also the stack. So these are some things that you might find yourself typing into PDB. And so the fact that it's got it right there on the screen for you is a nice little convenience. This is PDB-PP, which is PDB++. And the one, I pulled this one out because along with the syntax highlighting and a bunch of other stuff, it has this function that I really like, which is called sticky, which means that every time you advance, it repaints the source code printout. So you're not forever going like next and list and next and list. You just get that for free. Very last one is I will point out that there is a whole other world of graphical debuggers. This happens to be the one from PyCharm, which is, I haven't actually used that one too much, but it's kind of like PUDB in that it gives you for free this printout of all your locals. You can dig into any of like the native Python objects. You can set conditional breakpoints. It gets pretty deep pretty quick. So that is the subject for another talk. So I won't dig too much into that. And that's it. I hope that I've given you enough to maybe poke at PDB, see if it's your thing or not. It's a very lightweight, very accessible debugger, and I encourage you to investigate and explore. That's what I got.
All right, thank you very much, Emily. That was a very well crafted and presented overview of PDB, and I appreciate it very much. We had an ongoing question and answer stream going in the chat. I'm not sure there are any there that are unanswered. The latest one in there from Doc Jones is pointing out a site called pythontutor.com, which is a very interesting site, and it's kind of like a graphical debugger. It's not useful for debugging your own program necessarily because it's only good for small amounts of code, but it can be very good for understanding Python if you've got a little bit of Python and you just don't get why it's doing what it's doing. It will show you, it actually draws pictures of variables pointing at other variables and lists containing numbers and things like that. It's very cool. Paraksheet asks if there's a Python command line debugger that supports tab completion. Emily, does IPDB
does, I'm pretty sure.
Yeah, so IPDB I think comes from the IPython world, right? Right, and IPython has a command line prompt that does tab completion. So I guess it makes sense that their debugger would as well. For people who want to try PUDB, one of its advantages is it takes exactly the same commands as PDB. So if you're used to typing NNNSSRRR, you can just type exactly that at PUDB and it works the same. If any people have other questions, they can just unmute and ask a question. We don't have to be stuck in chat, which doesn't get in the recording. People are saying nice things. Awesome talk, Emily. I learned a lot more PDB shortcuts than I have used in the past.
I would want to mention one very useful command that that I think people might find helpful is B, to set a breakpoint. So if you say you see there's a function that that is called several steps down the line, you think, oh, I want to see what happens there, rather than stepping through to get to it or quitting out and setting a breakpoint there, you could type B and that function name, and it'll continue until it hits that. So that's when you're working with fairly complex code, that is a real lifesaver.
So that's a third way to set to get into PDB, basically.
Well, it's once you're in PDB, it's a third stop in a new place. Right,
you can choose where to start and stop.
Yeah,
that's right. Alex asks, is there a way to use PDB to debug a Unix-style standard in, standard out program? PDB seems to take them for the debug control, which of course it does. It needs standard in for you to type commands at it. I don't know how to do that. I guess you should, I don't know. Your program should also accept file names on the command line in the first place, I guess. I don't know.
I was going to say, it's not always my program.
No, yeah.
But I noticed the Perl debugger opens up channels, somehow manages to do this.
Oh, I don't know. I've never tried.
Okay.
Question, if I may. Why is it necessary to insert breakpoint or something into the source code? Why can't PDB just do what other debuggers do? Is just set a breakpoint and somehow inform Python that it wants to stop there?
Through what interface? Like a graphical interface?
No, just at all. Like the Perl debugger that somebody mentioned, you can start a program, it stops at the first, like main, whatever, first instruction, and then you can set a breakpoint. Why is it necessary to insert anything into the source code in Python? What is it about Python that requires to do that?
So I don't know about the specifics of why Python requires that. In fact, I don't think so. If we go back a couple of slides to how you can start up PDB, the option one, the first one that I didn't do, allows you to run PDB as a module, which does do the thing that you're talking about. It stops before any line has been executed, and then you can dynamically go through and set your breakpoints if you want.
Right.
Yeah, like Brian just put in the chat.
Using the B command that John Caparsi mentioned earlier.
Right.
And you can also do you can do things like conditional breakpoints and like you can have it automatically print out a thing when you land on that breakpoint, which is all really super powerful and stuff. But like for the most part, yeah, you might not need it.
Good, thank you.
Yeah. And there was a question and answer here in the chat about integrating PDB with unit testing like PyTest. PyTest, it's been pointed out, PyTest has a switch --PDB, which will, when a test fails, will drop you into the debugger, and you can start poking around to see what happened, which is very cool.
Super fun way to take advantage of that is to force your tests, like force the test to fail, and use that debugger failure to step into your code and help, and that can help you like reason about what even was happening in this code. Like if you're working with a legacy system that you're not familiar with, that can be tests combined with debuggers can be really powerful.
Mm-hmm.
I think I might be able to respond at least partially to Pavel's question. In conventional compiled code, the debugger works by inserting a specific machine instruction, a breakpoint instruction, at the designated point in the code. And that causes a trap to execute, which causes the flow of control to go to the debugger, which has set up exception handlers in that case. I would expect that in interpreted code like Python, the insertion of the breakpoint, the PDB breakpoint, has to also cause a change in flow of control to the debugger itself.
Right, and that's what running, as Emily said, running Python-m PDB basically means that your program is not the main program anymore. PDB is, and it knows how to set itself up and then run your program. So you start before the first line. You start in the debugger before the first line of your program. Just like Perl. I mean, I've never used the Perl debugger, but from the context of the question, it sounds exactly like the way the Perl debugger works.
Similar to GDB.
Yeah, so PDB, I think PDB and the Perl debugger both were heavily influenced by the GDB debugger and probably debuggers that came even before it in the Unix history. So there's a lot of similar looking tools.
Yeah, I tried in the background with my question. Yeah, it does exactly how you explained it. If you start as a module, it stops initially, and then I can set it. There's a command breakpoint.
Great.
I've never used it, so I just wondering where I could apply this. It's just fascinating that it works. No, it's very similar to the Perl debugger. Yeah. Thank you.
Yep.
And this is a really quick introduction to a very, very deep and complex tool. So if you're wondering why doesn't it do this, the answer is probably it does. And just Emily has spared us like the complete tutorial, which would have been a long night. There's things like a postmortem mode where you can have it pop out of an exception. It's a very magical device, and like any magic, you have to learn how to control it.
Right, and
Also,
go ahead, Emily.
I'll also mention that I did include as my very last slide a set of references that I used, so you can read to your heart's content about all of the PDB commands that I didn't cover once I post the slides.
Right, and Alex points out in chat that there is an H command for help inside PDB, so you can read about more commands. And we have a question about integrating PDB with Django and etc. So Django is a Python framework, and so it doesn't need any special integration with PDB. If you have a Django application, it's just a big Python program, and you can use PDB inside it. The trick is that where you're running your Django application might be a web server that you typically don't have a console on, so you might have to figure that part out. But Django itself, can be debugged like any other Python program. At work, we have a 350,000 line Python program, and I debug it. It's Django, and I debug it with PUDB. And occasionally PUDB doesn't work for some reason because full screening is hard, and I use PDB on those 350,000 lines of code. All right, any last questions for Emily?
Yeah, this, to Emily or anyone who might have had such experience, the most challenging debugging situations I've ever faced is in debugging parallel or multi-threaded code.
Yes, and Emily very wisely
trying to find race conditions.
Yes,
right. I've never done that in Python. This is in other more traditional languages, I guess.
Yeah.
Any tips on using on dealing with multiprocessing Python?
I'll point out that Emily cleverly mentioned that she wasn't going to talk about debugging that kind of program early on. Yes, and debuggers are really hard for those programs because the problems that happen with them happen when two things are happening at once, and the whole point of a debugger is to stop at least one thing from happening. Any experience?
Yeah, I will tip my hand here and say that 2 weeks ago I knew absolutely nothing about PDB, so I am no expert here. But I looked into it enough to know that it is possible that PDB handles async code. I'll say properly. Like it won't break if you try and look at async code, but my experience from other languages, mostly JavaScript, is that debugging async is more of a skill set and not a tool. Like there's no tool solution to that, as I'm sure you know. But PDB will handle it if you go down that road.
Yeah. If the problem is because of the concurrency, then a debugger is going to be the wrong tool to find it, unfortunately. And maybe that's an awesome segue into our second talk, which is about debugging without a debugger. What? Rick, how much did you pay Edward to ask that question?
I paid him exactly what I've been getting paid to write code for the last 5 years, which is zero.
That's too bad.
So, okay.
All right, so thank you, Emily, very much. You may have noticed Emily said that she didn't know anything about this 2 weeks ago and that this talk was a learning experience for her. Again, another reason to volunteer to do talks if you want to learn something. Rick,
kind of exhilarating. I said it's kind of exhilarating.
All right. It's kind of exhilarating. I should put that on the talks page of about.bostonpython.com. It's kind of exhilarating. All right.
Okay.
You're ready to go, Rick?
Yes, sir.
Okay.
Okay. Hi, my name is Rick Landau, retired software engineer.
Can you go into presentation mode on that?
No, actually. No. I've tried.
Okay.
And presentation mode in PowerPoint and Zoom do not get along as well as they ought to.
Okay.
So I tried to make everything quite large. Is it big enough to read?
Yeah, we'll manage.
Okay.
Not yet. I'm still.
Someone's got to mute. Andy, you got to mute.
Yeah.
Okay.
Just need to charge my.
Go, Rick.
Okay. Hi, Rick Landau, retired software engineer and Python junkie. I thought of a great title for this talk, but then I couldn't find a joke to go with it. I apologize. If you can come up with one, I'd be thrilled. So why a dinosaur? retired. I worked in the business for many, many years. I've used a lot of programming languages over the years, and Python is my very favorite one because it is concise and expressive, has astonishing libraries that go with it, and IPython and Jupyter just are amazing tools that I wish I'd had many years ago. Personally, I develop all my code on Windows with the Cygwin library. If you don't know what Cygwin is basically GNU running on Windows, and you can bring up a shell that runs very much like a Linux shell with real bash or real Bourne shell. I develop entirely on there and then run all my programs on Linux for production, and that works just fine. Main topic I want to talk about is offline debugging, and though I have a particular tool that I've developed, I'm not trying to peddle the tool. What I want to convey is lessons that I've learned over the years about how to make this kind of offline debugging efficient and effective. And I'll show you what I use and why. And I have real examples cut from real code that I will demonstrate as well. Offline debugging basically is intended to write a record of what a program does, or I should say did. It's not intended as a permanent record. It's just for debugging purposes. And it's certainly not intended as an activity log for auditing what a program did or what data it accessed and so forth. Though it certainly could be used that way, but it's not primarily what I've intended. Python does have a logging facility that is somewhat more appropriate for that kind of recording. Now, interactive debugging might not be possible. It might not be simple. It might not be possible. What? Oh, sorry. Get this crap off my screen. Why can't I?
Of course.
I'm sorry.
It's classic.
Yeah, right. It is.
Can you minimize it? Will it minimize?
No, I can't. Let me get a task manager here and see if I can kill it. There, can I kill it? No, crap.
It's down at the lower right.
Yeah, I know, but I couldn't. But unfortunately, the gallery is on top of it at the moment. So, okay. Sorry about that. As I say, interactive debugging might not be simple and it might not be available or practical at all. In particular, when you're running detached processes that don't have UI access, something like what Ned was referring to as part of a large web service. That's particularly where I have found problems in the past and had to go to a non-interactive kind of debugging. Some programs also have very lengthy or very complex setup. The last project I did that I will show some snippets of was very complex, and the setup took forever, and also had some very long run times, in some cases running into the minutes that were troublesome. So interactive debugging simply was not an option for that. So I felt I needed an alternative, a way of watching what a program did, looking at the way the code flows in a little bit of detail, maybe more detail than others at some times, and tracing the progress of data through the program. And for me, with the programs I've dealt with, after a little practice, I can actually debug faster with this kind of tracing log than I can with an interactive debugger. I've used interactive debuggers for many years on various programs, and I find them quite useful, just not for large complex programs that are detached in particular. So what one typically does when you have a program that doesn't do what you want it to is sprinkle a few print statements on it, which people have mentioned. And that's okay, but you can do a lot better than just sprinkling a few print statements in. The example I have here is available on GitHub on my area. It's called New Trace. It's basically print on steroids. And it has a number of other features that I've learned are useful from experience of doing this for a long time. Now, Ned is probably holding his nose. Go ahead, Ned, do it. Yes, good. Because the code that Ned has seen from me recently was some stuff I wrote in 2007 or 8 when I was just beginning to learn Python. And I was still writing C without braces, spaces instead of braces. And it wasn't very good. I didn't even use decorators back then, for example, which I do now. So I think it's improved a bit since then. So now when I say I'm going to try to impart some lessons I've gained from experience, I think things that I believe are very important to include. When I say experience, I mean the facility that I'm going to describe I originally wrote in 1978 for a large multi-process communication system. That's back in the days when computers were barely computers by modern standards. This thing started out in assembler, and I've translated it into half a dozen other languages since then. And finally, it's in Python today, because that's what I use today. So the first step anyone takes beyond print is putting in a sample decorator that prints something at the function entry and something at the function exit. This is available in every textbook, every tutorial, and the code looks something like this. You define a decorator that includes a wrapper function that wraps around the user's actual function. It does something before the function is called. It does something after the function is called. It kept the function's result and returns that to the user. Very standard stuff. And you invoke it simply by saying @ the name of the decorator in front of some function definition. And that works fine, but pardon me, we will get this correct. You can do a lot better than that. It can be improved in a number of ways. What I have learned over the years is that the ways I like to improve it that make me more efficient are that the output must have a timestamp down to the second or less than a second, must have the location, the source location that emitted the particular printing. That is, if you're using multiple processes, the particular process involved, or multiple classes, if you have a lot of class activity, what class it is, what kind of activity is going on. That activity might be function entry and exit, but it might be some sort of general processing. And here's some interesting data to look at. And the data certainly needs to be printed as well. And it needs to come in a very consistent, and it helps to be compact format. Now, I tend to use standard out for almost all output. Standard error is okay too, but file output is also necessary. If you're running something that needs to be part of a live system, such as a large web service, you can't break into a debugger to do something, but you can have it spit out a file of trace information that you can then go back and take a look at to see what happened. There's some other things that's very nice to have. It's very nice to have an adjustable level of detail of the printing that you're going to do. It's also nice to have HTML output once in a while. If you're spinning out a user's web page and the and the trace information can come out as HTML in nicely formatted separate lines, then it's a lot easier to read. It is also very nice to have a very low performance impact, so that you can leave this code in the production facility permanently or semi-permanently installed. And it would be very nice if it were thread safe or multiprocessing safe. I have done some thread safe versions of this, but wasn't particularly happy with them. They worked, but they were clumsy. And multiprocessing safe, that depends a lot on what your operating system is willing to do for you. The original version I wrote 40 years ago was multiprocessing safe because the operating system granted us exclusive file access when we were scribbling out into the file, but that's not always the case, in particular in Windows. And another really important lesson is that it must be easy to manage. You have to be able to manage certain aspects of the tracing without actually going in and editing the source code. You should be able to turn it on and off. You should be able to change where the output goes, either standard out or standard error or a file somewhere. And you should be able to adjust the level of detail being filtered, and in some cases, select only particular sources that you want to be traced at the moment. And I'll show how all of these are done. Okay. My current function does basically is meet almost all of those requirements. It's not perfect, but it ain't bad. So, okay, timestamp. I think every line that's traced out should have date and time down to the second or millisecond. All the examples I'm going to show here are from real code, real output from real code. So here we have code that generates a timestamp, and this is actually snipped out of the trace facility. Here's a function that creates a timestamp. It looks at some Boolean to determine whether you want a high resolution or low resolution timestamp, and it returns a stamp which is derived from the date time library, standard library. Now says when it is, and then the strf time function that formats the time into for this years, months, date, hours, minutes, seconds, and fractions of a second. Fractions is, I believe, microseconds, and what I've done is truncate all but the first three characters of the fraction. So I get milliseconds basically, and this is what the result looks like. It looks like 2020 1103. That's year 2020, month 11, day 3, 1537 in the afternoon, plus 3 seconds and 284 milliseconds. Okay, very simple to do, single line of code, but not something you want to type in all the time. It's something you want to isolate. Now I'll get to that in a sec. So, you want also, I said, easy control of turning debugging on and off. I find that control works best with environment variables. That's what I always use. Environment variables are easy to sense. They can be changed on the fly outside the program. You just have to restart the process when the parameters change, and that's all that's needed. Environment variables, if you're doing it in Linux and the bash command shell, you just say export some environment variable equals some value. And just be careful you don't put spaces around the equal sign. For example, the variable I use to control tracing is trace level, which is an integer. 0 being 0 or non-existent means don't trace, and anything greater than 0 will emit tracing data that's been specified at that level of detail. the way you detect this in a program is you just go to the os.getEnd function, tell it what variable name you want, supply a default in case that is not available, in case there is no such environment variable as trace level. It will supply this default. And then I try to turn that into an integer. But of course, since os getEnd always returns strings, often returns strings, sometimes I need to just take the default and turn that into an integer instead. What I have currently implemented in the package I use is level of detail, standard output or HTML output. What file do you want it to go to if we're going to a file instead of standard out? What facility code you want to trace or not, and I'll show how that's done later. Whether you want time in seconds or milliseconds, and there is a special trace production environment variable that turns off all tracing, except for itty bitty traces that you really always want. And it optimizes the code so that most of the code doesn't actually get compiled into the program at all. So, okay, I like to keep the debugging code in the production version. I don't think having a separate debug and non-debug version is a particularly good idea. You put something into production, customer calls with a problem. How do you deal with it? Well, if the trace code was still permanently installed in the production code, you just tell the customer to add a couple environment variables and restart the program or the system, and then email me the log file, and I can find out what's been going on. So, and yes, we actually did that. There are a number of places where code ran for years or a decade, actually, with debug code installed and proved very useful sometimes. So, where do you want the output to go? I say I always want it to go to standard out. There's a utility called less that is a wonderful thing. You just pipe the output into the less utility. Sometimes you need file output too, if standard out is not available, or in addition to standard out, as I say, optimal HTML, and maybe more than one at a time. So the way we deal with the output, you set a level of tracing to turn it on. You run Python on whatever the program is. I tend to combine standard out, which is file 2, into standard out stream, file 1, and then pipe that whole mess into less, so that just in case you have login or some error message that come out, it will come out in the correct place in the trace. So if you don't know the less utility, or if you use Linux at all, spectacularly good utility. So, okay, next thing, low performance impact. Without entering the source code, it's nice to have an environment variable that basically eliminates the code. The one I have, trace production, basically nulls out all the decorators, and it almost nulls out all the direct calls to a trace function to print something. I will note that in order to have this be effective, you need to recompile the program if you turn production on or off. Now, this simply means, I think, you go and delete all of the PyC files, the compiled Python files. They're lying around in the cache directories, and then run the system again. Takes a little longer to start up because it has to recompile everything, but the result is much better. So, production mode. In the actual trace function I use, the function ntrace is used to output a line. It says, well, If you're not in production mode, then put the real trace code in. But if you are in production mode, just pass. It doesn't do anything. Okay. And the same for the decorator functions. But these actually change the way the code compiles. If production mode is turned on, the decorator is defined as null. Essentially, doesn't do anything. It doesn't compile any code in. If you are not in production mode, then it defines the normal decorator foolishness that does whatever it does. And the way to invoke that is just turn on trace production equals yes, and then recompile. Okay, whoops. Now the package I use is one file. It defines one class. The class contains some functions to actually write traces, and you put these in the code in the place of the print statement you were going to put in there. And it does the print statement, but it adds the timestamp and a few other things so that it's readable when it comes out. And it includes the decorators that use those functions. And what I've done is create a singleton instance of the class so that if your program has 50 modules in it, which the last program I wrote did, only one instance of this ever gets compiled in and runs. So the singleton instance is done for efficiency. I think it's important to evaluate conditional code at compile time, like you saw with the decorators, and to read all the environment variables only once. Because reading an environment variable through os.getEnd is not a free operation. But if you do that once and then process it and just store a Boolean that tells some later code what to do, then that's very easy. So the import line that is all over my code says, from new trace, import ntrc, which is the singleton instance. Ntrace and ntracef are the decorator functions, which I'll get to. The singleton is done with a standard metaclass singleton that
I'll just
where from Active Python.
Wait, Rick, I'm just going to point out one thing. No one's allowed to use the words standard and metaclass in the same sentence.
Oh, so,
okay. What you're showing on the screen right here is super duper advanced weirdo code.
Yes, I apologize. I had to steal this from Active Python because I couldn't do it myself. Okay, so I went on. I borrowed their wonderful code, which is very brief and does use a metaclass. But the only code I wrote here, well, I wrote this, which is tiny, but then I wrote something. This ntrc instance is an instance of the singleton new trace class using their special metaclass foolishness. Yes. Thank you, Ned. I'm sorry. You're right. That's it's not simple at all. Now, the trace functions that I use, instead of print, I say ntrace and then give it a priority, which is a level of detail to be printed. One is very high priority, always gets printed, but later, 2, 3, 4, 5 are lower priorities, and they get printed only if the user requests so in the environment variable against which the program is running. And then an output line. And the output line can be constructed any way you please. There's also an ntracef, which takes the same priority, but it takes also a facility name, which is just a short string, 4 characters I tend to use, that tells me what the source of this printing is. Okay, and as I say, there's an instance of the class too that contains these functions. So here we have a simple inserted trace call. Okay, it says NTRC, which is the instance of the trace class. .ntracef, which is the function being used. 3 is the priority code. Read is the facility code. And then here's the output line. It says the activity I'm using is just ordinary vanilla processing. Okay. The function that's doing that processing is this weird function name. And here's the message, finally file not found. And I use, because I'm a dinosaur, the percent mapping of variables into output lines. I could use f strings. This code originally was written 7 years ago. The version that's running here was written 7 years ago when I started this extremely long project. It was Python 2 at the time, because some of the libraries we needed did not exist in Python 3 at that time. So you can also have a more complex one that substitutes more than one variable. This one takes 3 and just maps in the tuple containing the 3 variables you want to see at the time. And the result is a line with a timestamp, a priority code, a source location, an activity code, the name of the function from which the activity is being done, and then finally an output line containing the data that you wanted. It's only a tiny amount more work than just putting in the naked print statement, but the output is a whole lot easier to read when you have more than one line at a time. I have a much less simple example here, which I will just, people can read this later if they really care. Yeah, here's my apology for using percent values in the string instead of f strings, because I started with Python 2. I actually think it's more readable. If you take a look at this, here's this line that's going to be spit out, and I can see clearly there's a name of a piece of data, and then the data, then another name, another piece of data. And then here's this whole list of data. If I were an F string, that would drag on for about 200 characters. And it would be very difficult for the programmer to see, especially the maintenance programmer who comes after you've left the project, to see exactly what was going on. Okay, I think this looks like more readable. And lastly, yeah, dinosaur. Okay, I learned about %s about 40 years ago. So, and I still use it. But here's the output line that comes from that absurdly complex output. This is real code. This is cut right out of a piece of code that I ran. No. I will mention that priority level 0 can be used for lines that must always print, even in production mode. And I typically use that for like beginning and end of something. So here's the begin, and begin this simulation, and then end. Here are some time statistics. It took 4 seconds of wall clock time and 188 milliseconds. Okay, so now we have decorators. Oh, sorry. Yeah, decorators. There's an ntrace decorator and an ntracef decorator, almost exactly like those two calls, and the decorators use those functions to make the calls. Here, for example, if you just put @ntrace in front of a function, you end up with something at the function entry and something at the function exit. And the entry does list the args parameter list and the quargs list if there is one. And at exit, it gives the result code. Okay, whatever came out, whatever was returned by the function. You can also have one that basically includes a facility code, and I'll show you why facility codes are interesting in a second. And that comes out in the output line here. So you could search for all of those, or you can filter by it. And oh yeah, skip that. It's too complicated.
Yeah.
Filtering, we're getting right the end here.
Okay, we're getting there. We're getting there.
Filtering makes listings short and to the point. There are two environment variables that do this. There's trace level, which is an integer for level of detail, and trace facility, which shows the strings of the facilities to be included or not included, as the case may be. Trace level, I tend to use 1 for functions, 3 for most details, 5 for excruciating details. But it's just as simple as exporting that one environment variable, and that's it. Trace facility environment variable defaults to all facilities, and you can use all none, plus, and minus to customize it. For instance, you can say all minus foo minus bar, and you will get all facilities except anything that was declared as relating to the foo facility or the bar facility.
Okay.
Or if you wanted just those, you can say I want nothing else except foo and bar. Okay. And that is done again with a simple export for the trace facility environment variable, and that's it. And you get a much less elaborate listing. So I have more here. No. And that's it. There is more, but I'm afraid I'm close to out of time. So I yield my time to the floor for questions.
Rick, thank you very much. I think what everyone should take away from this is Rick gave us a really good overview of some of the characteristics that you'd really want to think about when deciding how to use non-interactive debugging. This library is available. If you like what you saw, you could go and use it. There's a question actually in the chat about the logging facility in Python, which has some of these features, not all these features, and they are, of course, expressed kind of differently. But is it solving some of the same problems? So you're going to find some of those features in there. Are there other questions? Rick, the chat got distracted onto what the heck is a singleton kind of chat going on there for a while.
I'm sorry.
That's okay. Half of it was my fault, to be perfectly honest. But so, are there questions for Rick? I am gonna do a quick 5-minute surprise lightning talk here at the end. Once Rick's questions are done, if there are questions for Rick.
I actually do have a question about the logging question. It's and it's basically, is there a reason that that you didn't just go straight to the logging module and dump this stuff into logs and then write a few little quick decorators to put the timestamps on things?
Okay. There are several kinds of answers to that. One is the system I was developing does use logging as well for certain information and uses tracing only for debugging information. So I was already using the logging facility, and I had to customize it a lot to make it a more compact format. The default date and time that logging prints is ugly, not compact, and not sortable. So they're very, very difficult to search and sort. So yeah, I do use it. And I will say this, as I say, this facility was developed 3 decades before logging was born. So, you know, it's sort of, I got used to it. You know? And if I could show you the output from one of these, which interleaves logging for certain kinds of information with the tracing for certain other kinds of information. The logging is for things that really happened that we wanted an audit trail for, and the tracing is just for debugging, okay, and is turned off 99% of the time. So
there's a question in chat of what is a facility, and I think in this case it's a very squishy term that just means a chunk of your program.
Well, okay.
Right? There's no more technical definition than that.
No, right, no. It was, I'll give you a 25 words overview. The thing I was doing, the most recent project was a library, simulating libraries and trying to preserve collections of documents. So there were libraries, the major classes, libraries, collections, documents, copies of documents, servers on which documents are stored, and so forth, okay? And so each of those I labeled as a facility. So every time something happened to one of the servers, like it died or it lost a copy of a document, or one of its storage units failed or something, that would get traced out as the server facility had a problem. Every time we did something with a document, like made a copy of it or lost a copy of it, it would come out as a document facility. So that was like that. Originally, the facility was for the program in a communication system with a dozen processes. Which process was doing what at what time. As I say, we put those all into a single file, and the timestamps allowed us to interleave them properly and understand what was going on. So facility is, it's a squishy idea. It's a major portion of the program. You don't have to use it.
All right, thank you, Rick. If there are no more questions, I am going to give you one tip about printing. If you're going to use print statements, I have one tip for you, which is that you should use repr. And let me explain what I'm talking about. In Python, there are two ways to turn an object into a string. One is str, str, and one is repr, repr. And the way I think of it is that str is for civilians and repr is for developers. And repr stands for representation. It's designed to give you an unambiguous representation of your data. And just to show you a few ways to do this, I've made a function here, which is you're going to pass it an argument x, and it's going to print x in a few different ways. First, it'll just print it, and then it'll print it with a little label before it, and then it'll print it.
I think can everybody see?
Did I not
share? You can't see your full screen. Yeah, it's very narrow.
Okay, hold on a sec. Let me try again. I moved the window after I shared, which is probably a bad idea.
Yeah.
How's that?
Much better.
Okay, sorry.
Much improved.
So there's a function here called showIt, which is going to take a value, and I'm going to print it a few different ways. Just print the value, print it with a label, print it with a label with the new f-string way of doing things. And then we're going to use this function called repr, which is going to give us a string which is the representation of x, and we're going to print that. And just to show you what it looks like when we do this with 1, 2, 3, 4, 5, it kind of looks all the same. Like there's no, what's the point? But let's try showIt of A, B, C. And now you can see that here, when we print it plain, you just get the ABC. But when we print the repr, you get the quotes around it. And this is a good thing for a couple of reasons. One, suppose we had the string ABC, space, 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 space. Now, these two lines look exactly like these two lines. You can't tell the difference because you can't see the spaces at the end. But these lines look very different. The repr with the quotes has let you see all of the white space in your string. And if we say show it and we give it a string that has some new lines in it, first of all, the new lines make our output very confusing. Now we've got two lines where we were expecting one line, but with the repr, it puts in the \n, which not only keeps it on one line, but is unambiguous about what it is we've actually got in the data. And for example, if we take 1, 2, 3, 4 versus 1, 2, 3, 4, Notice that our regular lines where we just print the value, it looks exactly the same. We can't tell what type the data is. Using repr, we can see the quotes mean it's a string, whereas the repr here, without the quotes, we can tell it's an integer. So in a very compact way, you get not only unambiguous output for your debugging, which is what you need, right? I'll tell you why your program doesn't work, because there's a new line at the end of that string. You just can't see it. So if you used a repr, you'd see the new line. And it gives you the type. So the type isn't explicit, but you get a really strong hint there about the type. And I want to mention just one thing that I threw in here. New in Python 3.8, a new feature of f-strings, is that if you put an equals at the end of the curly braced expression that the f-string is printing, then it puts in the name for you automatically. So it prints x equals and then the repr of x. So not only does it automatically put in the name and the equals, but it automatically gives you the repr of the variable too. So if we look down here, we get, look, x equals quote 1, 2, 3, 4. So that's my big tip about printing, which is whatever format you use. So Rick, because he's a dinosaur, is using % formatting. In a % formatted string, it's %r to get the repr of a thing. Use %r. If you're going to use older f strings or .format, then you can use the bang r option in the format thing. And if you've got 3.8, then you can use the equal. However you do it, use the repr. That's my tip. Any questions? No? All right.
How does that look with, how does repr look with an object or something more complicated than an atomic thing?
Let's take a look. Do I dare try to make an object on short notice? Well, so for instance, if we, well, here we go. I have an object. I have a function. So in this case, repr and stir are the same. And that's often true for the more complex objects. So for instance, if we give it a list, then you'll get the list the way it looks. One thing to note is that since we're talking about stirs and reprs, lists, when they print, always show you the repr of the elements. So even if you call stir on the list, it will call repr on its elements. So you'll see the one has quotes around it no matter how we printed it. And because the lists stir and repr are the same, they look the same too, whether we used stir or repr. If we make our own object here and try to show it, then we'll get, you've probably seen these kinds of doodads before, but you can also define your own way to do these things. Let's make it look, how should we make it look? I don't know, let's make it look weird just to prove the point. I'm making this up as I go along. Thanks for the broken type ahead, Jupiter. Okay. One more. So in your class, you can define your own dunder stir and dunder repr methods to control how your own objects get turned into stirs and reprs. And so you can see for the first three, we got our stir method called, our dunder stir method called, got a thing. And for the last three where we're using repr, we got the nerdier square bracket representation from our repr method.
What if you made thing a data class?
Yeah, come on.
All right.
I don't know, data classes are cool. But this is...
I think one of the advantages, don't they give you like a nice repr for free? Or am I thinking of adders for that? Maybe I'm confusing.
They probably do. Let's Where's my scroll bar? Let's see what it looks like. Yeah, so when you make a data class, which is a very compact way of declaring a class that has attributes, you don't have to write it under a init. It makes it all for you. You can pass in your X and your Y, and then it automatically gives you a nice str and repr, which are the same in this case, because it doesn't know how, what difference to show you. Any other questions since I put myself in the hot seat? Thanks a lot, co-organizers, for the awkward moment. Okay.
You opened the door, Ned.
I know, I did. That's fine. It's fine. All right, open mic. We've got a few minutes left. If people have any questions about debugging or other things, we came up with 2 topics for future talks: how to do decorators and how not to do singletons. So that's cool.
And also why to do decorators and why not to do singletons.
Yes. Well, of course, we'll include the motivation. That's part of any good talk, right? All right. So Mike Combs asked, when you define a dunder repr, do you always make it a 1-line output? Yeah, that would be. If you make the repr or the more than 1 line, it's sort of undercutting one of the values of the repr. All right. John's about to say something.
Nice.
Hi.
Can I say something?
Yeah, go, Mike.
Yeah.
I know you're just putting John on the spot as one of the.
That's okay.
The code needlers, the neddlers. So I noticed in Rick's code that he had a try this else that to see if the environmental variable existed and then set it, and if it didn't exist, set the default. It was like 4 lines. But I always write it as if the environmental variable exists, set it, if and else, give it the default value. And I just wondered, why is try a preferred method than like if it exists?
No, I didn't. Well, I think I did not want to go into os.sum function twice.
Oh yeah.
To check to see if it exists first and then do it. But since I carefully do that only once anyway per run of the program, if you're doing something once, you can take as long as you want. You do it 1 million times, you have to be really careful. So, but yeah, I could have written it that way. Yeah, I think, but it would end up going to os.something twice. So,
okay.
So it probably doesn't apply in this case, but sometimes you might see code that uses try except where a check and then do would have worked, and sometimes you want to avoid check and then do because, just to go back to the thornier topic from earlier about concurrency, checking and then doing can introduce what they call a race condition, where depending on how multiple things are happening at once, it might not be right to check and then do, because between the time that you checked if it already existed and then you did the thing, something else might have made the thing exist, or it might have made the thing not exist. And you may come across codes one day where it looks like, why did he check the thing? And then he checked it again, and then he did a thing, and then he checked a thing. And the answer is probably going to be, you have to think about what happens if you have 4 processors all running this code at once in a tight loop,
right,
and
right.
the 1,000,000 chance of something going wrong.
Yeah, well, argv runs into this all the time. If you try to access, you try to say, well, if argv of 1 is something, sorry, it's not defined half the time. You get an error immediately. You have to say, no, you have to touch it to see if the length of argv is greater than something before you dare touch any of those. So,
okay, no, that's a light bulb for me. That helps a lot.
Yeah.
Just a habit I can change.
I literally fixed a bug like this over the weekend, where I had code that it needed to write a file into a directory. So first it checked if the directory existed,
Yeah.
And if it didn't, it tried to make the directory. And every once in a while it would fail. And that's because two guys at once both checked it didn't exist. One of them made it, and the next one said, now I'm going to make it. Oh, that fails because it already exists. Classic.
Good, good.
Well, lots of four. Yeah.
Isn't it more?
Were they two threads or two processes?
They were two processes.
Okay.
In this case.
Isn't it more considered more Pythonic to write, assuming the happy path and liberally catch exceptions, than to branch a lot with if else's?
Yeah, Python is very comfortable with exceptions. And coming from other languages, there are other language cultures where exceptions are considered too expensive and they're avoided. But that's not the case in Python. And dealing with exceptions does get you out of that trap of checking and then doing and something changing behind your back between those two steps.
I had one thought for you, Rick, while you were talking about the need to reset when you change their environments.
Yes.
I do not know, actually, I realize that I'm pretty ignorant about this, but I know that you're running on a Linux platform, and Linux has a mechanism for telling a running process that something has changed. Is it possible that you could catch a signal, like send kill some flag to this?
Right. Yeah. Well, I suppose it's possible. I would prefer not. Well, how often would I have to check that? And the question is, would that have to be checked every time it goes to do something? Or I don't know. I have not done that at all, I have to admit.
I guess the question is like,
I have not
yeah. How does Python handle Linux type interrupts?
I have not intercepted any kills at all, so I really don't know how that's done. Maybe Ned can tell us.
No, I can't. Interrupts, I mean, those are scary. That's introducing concurrency into a program that didn't have any before.
I've done that for a Linux program. You just have to establish, like I established a handler for hang up, which is, I think, the convention. And then in that you set a flag and, do something when you get around to.
Mm-hmm.
You shouldn't do anything in the signal handler except set a flag, or you do get into serious trouble.
Right.
Yeah, but then
you have to check the flag sometime.
Right, and everybody has to check the flag every time they do anything, and that's one of those.
The nice thing about this sort of thing is, you send the signal, and it just means sooner or later, the update will be noticed.
Okay.
No guarantees.
And by the way, just since we're talking about jargon, flag is an old timer's word for a variable that can be true or false for some reason.
That might not actually be a Boolean, but is truthy or falsy.
Fine.
Okay. Right.
Yeah. Exactly.
Semaphore is slightly different.
Just pointing to the origin, which is semaphores.
Yeah. Well,
Either
that was
the flag
chat.
is up or it's not.
Yeah. All right. Thank you, everyone, for coming. As I mentioned, we have office hours every Monday at noon. We're going to have a project night pretty soon here, and we're going to have another presentation night in March, although I don't know what it's going to be. Maybe someone is fascinated to talk about decorators or singletons or concurrency or flags or interrupts. We've had a number of interesting tangents started here that could be fully developed if someone were interested.
How to decorate your singleton with flags.
Yes. Yes. You know where to find me and the rest of us if you want to. We're in the Slack workspace. The Slack invitation is in about.bostonpython.com/Slack. And we're all very friendly and helpful. So come and join us. And we'll see you at the next event. Thanks for coming.
Great.
Bye.
Bye, everyone. And thanks to Rick and Emily for doing an awesome job with their talks.
Bye.
I like that Rick had 30 years experience with what he talked about, and Emily had 2 weeks experience with what he talked about.